think I'm good. Okay, number one, I gotta graph it. Okay, so I'm gonna get a piece of graph paper out. And
I think it fell actually. I think it fell off the rod. I see two ones that are taking really
okay. Let's see, I gotta get to 13. All right, here we go. Number one. I'm gonna graph it, and I'm live. Today's date is the 22nd. 22. Okay. No, Novembre. Novembre. 04. I think I might go by twos to make everything fit. 2, 4, 6, 8, 10. All right, here we go. 04, 1, 6. I'm going by twos. 2, 9, and 3, and 13. I get 13.5 is me about there. Okay, it definitely looks like it starts to curve a little bit. It is exponential. And so since it's exponential, I'm going to use I don't have a lot of formulas, but the one formula that keeps popping up is this: y equals ab to the x. Okay, that's my exponential equation. Hopefully that's in your notes somewhere, right? Well, I know a is the beginning amount. I know that's 4. That's a. A is right there. It's 4, okay? So I know a is 4, which I will put there. I don't know b, but I could probably figure it out. And if you can't determine what's going on, again, I want to put this up here. One way to find the value of b is take the second one and divide it by the first one. That always works. If you can't find the value of b, take the second value and divide it by the first value. So I'm going to have 6 over 4. Or 1.5. So it's growing by 50%, so it's growth, 1.5. So here's my equation. If I go going too fast, will you tell me to slow down, please? Okay. So I'm going to write y equals, I know a is 4. B is the growth rate, 1.5 to the x power. Okay, that's my answer. That's the equation. How am I doing? All right. Number 2 says graph. So you can graph this. You can graph this by creating points, and I'm going to do that with you. Or you can graph it just knowing what's going on. But I'm going to try and take the easiest way for you to understand. Okay? Oh, I may have to use a separate sheet of paper. I might use a separate sheet of paper on this one. Okay, it says let x equal -1, -2, and -3. So if I have a calculator, these are like points. And Tay, this is kind of what you and I did this morning. So you got -1, something, 0 something, you got a 1 something, a 2 something, and a 3 something, okay? So I'm just going to create these points. I'm going to plug them in for the value of x. You may as well use a calculator, right? And let the calculator do the work for me. All right, so let the calculator do the work. I'm going to go 40 times 1/2 to the power of -1. I get 80. Okay, all right. So I'm going to put 80 right here. And then I'll go 40, and I'll multiply it by 1/2 to the power of 0, because I'm just going to plug a 0 in for my x value, and I get 40. Any questions about what I'm doing? I mean, please ask. If you are totally lost, please ask me, okay? So I'll put in this next value 1, I'll plug it in for x, and I'll use my calculus. So much easier if I use my calculator. 41/2 to the 1 power. I'm going to get 20. Do you see what's going on? Do you see the pattern? So I could probably make the next term. What do you think the next term would probably be?
10,
And then?
5.
Sure. I mean, and if you use the calculator, you're going to get those answers, okay? You really will. All right, so I'm going to graph this. And okay, I'm probably going to have to go by 10, so I'm going to get 80 in there, so I'll probably go by 10, 20, 30, 40, 50, 60, 70, 80. Okay. 1, -1. Okay, and then I'm going to just start putting the points in. I'll go -1, 80, 0, 40, 1 and 20, 2 and 10, and 3 and 5. Definitely exponential. Definitely exponential. It's got that curve. Right? Now the domain. I would like you to put in the asymptote, okay? I really would. The asymptote is right there. It's an imaginary line that is a boundary that keeps it from touching the x-axis, right? My asymptote has an equation of y equals 0. That's my asymptote. Now the domain. Let's take a look what's going on. Domain is like x values. That's what domain is. So my domain is really my x values. All possible x values. So I can plug in anything. I mean, think about this. I can plug in any number I want for x. I mean, I plugged in -1, 0, 1, 2, 3, but could you plug in, you could plug in 1,000. You could plug in a -1,000,000. Or another way to look at domain is how wide is the graph? It's forever going this way. Even though it's going up and up and up, it's always migrating back. And it's always going this way. Even though it's going smaller and smaller, it's always going this way. So we're going to say, in this example, our domain is x equals all real numbers. Tay, you asked a good question this morning. You said, is it always all real numbers? And I said, yes. So that's an easy question, isn't it? Easy question. Is it always all real numbers? Yes, for exponentials. The range is different, because to get the range, you're talking about the y values. Well, there's no y, but I mean, this is the y-axis, right? That's the y-axis. There's nothing down here. It never goes down here. The graph always stays above 0. So we're going to say y is greater than 0. Thumbs up? Good, 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 good. That should be an easy question tomorrow. All right. Did I take that away too fast? Maisie's got it. Okay. Let's look at number 3. So they need to be the same base. Let me write that down. Same. We need the same base. And they both have a base of 4. Ah, this is an easy one. They both have a base of 4. Yeah, Ron?
For the last one, did you, I might have missed it, but did you cover the domain?
I did. It's all real numbers.
Okay, yeah, that's what I thought.
Yeah, all real numbers. Okay, thank you. All right, let's go back to 3. They have the same base. Base 4, base 4. You guys agree? So if it's 4 to something, then you just cross out the 4s. Boom. Then you can have a x plus 3 equals a 5x plus 3, right? I'm going to solve. Let's see, I'll go minus x. 3 equals 4x plus 3. I'll go minus 3. That gives me a, I'm running out of room, but I'll scoot over here. I've got 0 equals 4x. Don't let this number bother you. Don't let this number freak you out. 0 divided by 4 is 0. 0 is a number. 0 is a real number, so 0 is the answer. X equals 0. Okay, thumbs up. Okay, 0 can be an answer. Good. Okay, number 4. I may need a separate sheet of paper. That's okay. I'll do 4 on a separate sheet of paper. I run out of room. So what's my base? Same base. What's the base? What am I going to change 8 into and 32? It's going to be the same base.
4.
I can't change 8 into a 4 or 32, really.
Base 2.
Yeah. Base 2. So I know that 8 is 2 cubed and 32 is 2 to the 5th. You guys have your notebook, right? Do you have your notebook with all of those ones we wrote? And that'll help. That'll be really helpful. So let's rewrite this. So I'm going to write 8 to the... no, I'm not. I'm going to write 2 to the 3rd times x. And write 2 to the 5th times an x plus 3. Give me a second to circle the numbers. Hi, how are ya? So there's my 8. And there's my 32, okay? All right? Now, what I'm going to need to do then is just get rid of the 2's, right? I'm sorry. So, let's get rid of the 2's. Boom, the 2's are gone. Because I got 2 to something, 2 to something. And then I'm just going to solve. I have a 3x equals a 5 times an x plus 3, right? I'm going to distribute 3x equals that times that. 5x, 5 times 3 is 15. Okay. I'll go minus 5x minus 5x. Negative 2x equals 15. Divide by negative 3. Divide by negative 2. Golly, it's Monday, huh? Divide by negative 2. And x is negative 7.5. Or 15 over negative 2. That works for me also, okay? Thumbs up. See, 1, 2, thumbs up. 3, 4, 5, 6, 7, 8. All right? Talon, thumbs up. Good, there you go. Okay, number 5. So number 5, you're going to earn. So is this going to grow, or is this, you're going to put money in the bank? Is the money going to grow at 3% interest or decay? Which one's going to happen? It's going to grow. So I want to use this amount is equal. We're going to put in A1 plus R to the T, because it's going to grow, right? It's not like a car. So I'm going to write A is equal to 20,000. That's my amount. Parentheses 1 plus 0.03 to the T power. And we talked last week about why the 1 is so important. 1 is so important. You go to the bank, you put $20,000 in the bank, you put 20,000 in, right? You put $20,000 in the bank, you come back and they give you $100. If you don't have the 1, you won't get your original 20,000 back. Does that make sense? You gotta have the 1 there. Otherwise, you're like, where did my 20,000 go? No, that would just be the interest. Okay, there's my equation. And then what's the balance after 6 years? Well, I'm going to go, my amount after 6 years will be 20,000. 1 plus my 0.03 to the 6 pound. I'm just going to use my calculator. Make sure you can do this. No phones tomorrow, but you can use my calculators. 1 plus 0.03 to the power of 6. And after 6 years, I got about $23,881 and about 4 cents or 5 cents. Thumbs up? Let me see. Any sideways thumbs? People are good? All right, awesome. Okay, 6. You buy a car for $32,999. It will depreciate. So I'm going to use my formula, but I'm going to use the one with the minus. I'm going to rewrite this formula, but with the minus. So I'm going to go, okay. I'm going to go, all right, A is equals my beginning amount, 1 minus, because it depreciates. It's going to go down, R to the T power. It's going to go down. So I'm going to go, okay, amount equals, see, I'm going to start with, it's my starting amount, $32,999. 1 minus 0.08 to the 2 power. Or, Talon, we could put it as 0.92, right? Awesome. Now, 10 years, we're just going to put 10 in for t. I'm going to go, okay, the amount after 10 years is 32,999. 1 minus 0.08 to the 10 power. And I'm just going to use my calculator, right? 32,999. 1 subtract 0.08 to the 10th power. Okay, it went down a lot, almost, wow, it depreciated a lot, 14,000. But 10 years old, right, it's an old car. Actually, that's not bad for a 10-year-old car. That's not bad at all. Somebody must have taken care of the car. Yep, good job, Artie, yep. Ready to turn the page? Okay, let's turn it. All right, number 7. Well, geometric sequences. So if, when you see this word sequence, I want you to write this. I want you to write this down. Okay. That's our formula for a geometric sequence. Write that down, please. When you see the word sequence. The reason we do the n minus 1 power is because you don't have a 0 term. Okay. Now, how does this work? Find a geometric sequence to model this. Well, all right. I'm going to go a of n. Okay, what's my first term? 144, right? That's my first term. What's the multiplier? Well, I don't know, but I do know if I take and divide the second one by the first one, I can get my multiplier, my ratio. Okay, so if I take 96 over 144, I'm going to use my calculator. 96 divided by 144. Okay, 0.666666. What's that number as a fraction? Good. 2/3 to the n minus 1 power. Okay, that's my formula. Okay, so not hard. The first term is your a1. To get your multiplier, you divide the second one by the first one. Okay, easy. Now, if I want the 8th term, I'm just going to let n equal 8. All right, I can do that. A of 8 equals 144 2/3 to the 8 minus 1 power. I'm just going to use my calculator. Okay, I'm just going to put it in my calculator. I'm going to go, okay, 144 parentheses 2/3 to the power of 8 subtract 1. About 8.43. I would just go 8.43. 8.43. How am I doing? Can you do this tomorrow? All right, I like that. I like that a lot. Okay, the chart. So let's complete the chart. Okay, I got 1.2, 3.6, 10.8. What's going on? Do you see? If you don't see, we can do this, right? If you can't figure out what the multiplier is. But does anybody see what's going on? It is increasing, so let's find out by how much. So it's by 3. So if you don't see that, if we don't know what it is, we can take, okay, 3.6 and divide it by 1.2, and that is 3. It is 3. In fact, you can check it. If you're confused, so I think it's, you can go, okay, what's 1.2 times 3? Boom. Times 3.6 times 3. Boom, I get that answer. Okay, so then times that by 3. I get a 32.4. And then if I times that by 3, I get a 97.2. And if I times that by 3, I get a 291.6. Okay, how am I doing? Yes?
Could you go back to 7B?
7B, yes.
Because I did it in my calculator and I didn't get 8.43.
Okay, so let me see. You could, well, you got the old calculator at your phone. So here's what I'm going to shoot. Your calculator took the 8th power and subtract 1. So you're going to be smart. Old calculator, just going to go and do it to the 7th power. Do it again. 124. Yep. Get me on the 7th power. Okay, nice one, right? You have an old, easy up now. Pick up one of the old ancient calculators. It doesn't do things fancy way, okay? Okay, so I've completed the chart. Now write an equation. Okay, so that's easy. I'm going to go, and I give you the equation, y equals, okay, what's A? What is A? Help me out. What's A? What's the value of A? What? A is 1.2. Good. What's B? We know what B is. What's B? It's 3. So here's my answer. Y equals A, 1.2 times the B, which is 3, to the x power. Okay? All right, now, these are growing over hours. You see that? These are growing in terms of hours. So how many are left in one day? Well, gosh, how many hours are in a day? Yeah, so let's let x equal 24. 1.2 times 3, 24th power. Okay, 1.2 times 3 to the 24th power. Ooh, and I see the E negative, see the E11? What does that mean? I got to move the decimal 11 places. Or I can go 3.89 times 10 to the 11th power. That's a lot of bacteria, right? You okay with that? Have you guys learned scientific notation? Hopefully you have. Nope, never? Yes, you have. You guys have learned scientific notation. You haven't? Okay, so this really means times 10 to 11th power, which really moves the decimal 11 places, okay? All right, number 9. Okay, put this in because your extra credit is like this, okay? Would you like me to do it, or do you want? Okay. So what do we know? What's the base? What's our base? What's the base? What should be the base? 2 is right. So we know that 8 is 2 cubed, and we know that 16 is 2 to the 4th power. Are we good on that? All right, so let's do this. I'm going to go 1 over, all right, 2 cubed. I'm going to go 2 cubed to the x plus 3 equals 2 to the 4th times a 2x plus 1. Okay, now here's the extra credit trick. Anybody know what to do? Just throw it out there. What should I do? Teva?
Wait, never mind.
Anybody remember what to do? Whoa, smart girl. Remember, if we have negative exponents, it makes a fraction. So I'm going to write this as a 2 to the negative 3 times x plus 3 equals 2 times 4 to the 2x plus 1. That's the trick to the extra credit. Right? You probably would have got it. Cancel, cancel, and then you guys can go from there, okay? Nice job, Carla. All right, that's all I have. Let's take a mass break. We'll come back and I actually have a worksheet for you to practice this, okay?